The solar system, our little neighborhood in the cosmos. At a glance, it feels simple: 8 planets orbiting around a single star. A cosmic dance, orderly and predictable. But the more we learn, the more it reveals itself not as a peaceful stage, but as part of a much grander, more chaotic theater, layered and humming with unseen forces. The planets do not just orbit. They do so in a flattened disk, each tracing a path inherited from the cloud of dust and gas that birthed the sun. It is like a racetrack suspended in space. This is not a coincidence. Billions of years ago, a swirling, rotating nebula collapsed under gravity. Its momentum flattened it into a disk, and from that disk, the planets were born. That is why, from Mercury to Neptune, they more or less stick to the same plane. But not everything obeys that order. Mercury is tilted. Pluto, now a dwarf planet, tilts even more, about 17 degrees. And comets? They do not care. They swoop in from wildly different angles, crossing the plane like spears from the dark, ancient corners of the solar system. So, here's a strange question. If the planets orbit in a flat disk, what lies above and below it? On Earth, that question makes sense. Up is the sky, down is the ground. But in space, there is no floor, no ceiling, no up at all. Direction becomes subjective. Floating in orbit, an astronaut could be upside down relative to another, and both would be right. Orientation in the universe depends on your point of view. Still, astronomers needed a reference, and they chose the planetary plane, the ecliptic, as their guide. When we say above or below the solar system, that is the line we are imagining. And what we find above and below it is astonishing. Start with the Oort Cloud. It is not a disk like the planet's orbits, but a vast, spherical shell, an invisible snow globe surrounding everything. Scientists believe it stretches as far as 100,000 astronomical units from the Sun. That is roughly a quarter of the distance to the nearest star. Imagine that, an icy sphere so massive it envelopes the solar system from every direction. Inside are trillions of frozen fragments, leftovers from the early days of planet formation. Long ago, some of them were flung outward by Jupiter or Saturn, escaping the chaos of the inner system but never quite leaving the Sun's gravitational pull. They remained trapped, suspended in slow, distant orbits. We have never seen the Oort Cloud directly, but long-period comets, those that take thousands or millions of years to return, are our messengers. Their paths cut in from extreme angles, hinting that they originate from a source far beyond the flat, icy Kuiper belt. From everywhere, from all sides. That fits the Oort Cloud model, a cosmic sphere of icy debris. Then there is the Heliosphere, a protective bubble around the solar system formed by the solar wind. Our sun constantly emits a stream of charged particles, flowing outward in every direction. This wind carves out a cavity in the interstellar medium, the thin soup of gas and dust that fills the galaxy. At the edge of this bubble, the solar wind slows down and begins to interact with the material from interstellar space. That boundary is called the heliopause, and it marks the frontier between our sun's influence and the galaxy beyond. But the heliosphere is not a perfect sphere. It is shaped like a teardrop, compressed in front, stretched behind, distorted by our motion through the galaxy. Think of a boat moving through water. Waves build up at the front, and a trail forms behind. That is us, sailing through the Milky Way, with the sun blazing ahead like a galactic engine. We are not drifting through emptiness. We are currently inside the local interstellar cloud, a denser patch of gas and dust. The sun, speeding at around 828,000 kilometers per hour, is passing through this region, just one waypoint in our endless galactic voyage. And beyond it lies something even more mysterious, the local bubble. This bubble is not made of gas or particles, but of absence. It is a void, a region about 300 light-years wide with significantly less matter than the surrounding galaxy. Scientists believe it was formed millions of years ago by a series of supernovae, stellar explosions so powerful they cleared out everything around them. Now, the solar system travels through this hollow, its walls visible only as denser regions at the edges, where gas and dust were pushed and piled up by ancient blasts. It is hard to imagine. A massive, invisible room in space, carved by the deaths of stars, and our solar system, like a dust mote, drifting silently within it. The walls are real, the void is real, and it is only one of many such cavities scattered throughout the galaxy. These structures, above and below the planetary plane, remind us of a powerful truth. The solar system is not isolated. It is not just planets circling the sun in neat, predictable orbits. It is a ship, surrounded by layers of cosmic debris, interstellar clouds, magnetic fields, and ancient scars. It moves through space, bumping into invisible walls, carried by forces we are only beginning to understand. And the galaxy itself is not a flat disk either. It is warped, twisted. Its edges ripple like waves. It has a central bulge, spiral arms, and a spherical halo that stretches far above and below the galactic plane. That halo contains ancient stars, globular clusters, and possibly massive amounts of dark matter. It is quiet, but it is massive, and it surrounds everything. This concept of vertical structure, of above and below, gives scientists a way to understand motion and history in our galaxy. By studying how stars move relative to the galactic plane, we can uncover where they came from, how starbursts happened, where supernovae exploded, and how gravity sculpted the Milky Way's evolution. Even dark matter, the invisible glue of the universe, might be mapped through these movements. So next time you see a diagram of the solar system, those neat rows of planets, that tidy, two-dimensional view, do not be fooled. That is just one layer, just one slice. Reality is three-dimensional, dynamic, alive. The planets spin, the sun breathes particles, comets dive in from above and below, and our entire system drifts through colossal structures shaped by forces older than life itself. And here we are, a fragile blue dot, balanced within it all. Life, complex and self-aware, emerged not in the calmest part of the universe, but in the middle of this celestial turbulence. The fact that we exist, that we can wonder about what lies above and below, might just be the most astonishing fact of all.